So today we're going to talk about the fun chart and our first and second derivatives and how all these things tell us and how they relate to each other. So some of the stuff we know, some of the stuff is new. The fun chart is just a way to organize all this information kind of graphically, so it's an easy reference, and we'll use this pretty much for the rest of the year. So for our fun chart, for our function, because this is the fun chart, this would be fun, and then we're going to have an up arrow for increasing and a down arrow for decreasing. So that's what's happening on our function line. And the way that our derivative relates to this, so our derivative is increasing on this interval and decreasing on this interval. And this is kind of new with this concavity. We'll talk about what these shapes mean here in a couple of minutes. And now when we get over here to our function, we already know that if the numerical value of my derivative is positive, then my function is increasing. And if my derivative has a negative value, then my function is decreasing. And so there's another new piece to kind of go along with this. We have our second derivative, and we'll learn more about the second derivative test later today. But if I have this second derivative, and kind of like my first derivative, if my second derivative is positive, that means my function is increasing. I'm sorry, my derivative is increasing, and my function is concave up. If my second derivative is negative on some interval, that means that my derivative is decreasing and that my function is concave down. And again, we're going to talk more about this concavity here in a second. So we're going to jump back over to our notes. I've already got some of this stuff filled in. I put a copy of our fun chart right here, and you guys are going to want to use this, and we're going to write this like all the time. So kind of thinking about concavity, right? And you can kind of think of it like a bowl. So if we have a bowl shaped like that, shaped up, this would be concave up. And if it was shaped the other way, this would be concave down. Now, just because it's concave up like this, we could also have it be concave up, right? Individual pieces. So it's like we separated this bowl out and moved the two pieces to the side. And the concave down could be the same thing. So it doesn't have to be concave up on its entire interval. We could be looking at just pieces of this graph or different sections of a graph to see concavity. And so we'll talk a little more about this. So if the graph of f, our definition of concavity. So first off, the function has to be differentiable on some open interval, and the graph of f is concave upward on an interval I. And so concave up is going to look like our bowl or our cup that's opening up. And if the graph of f is concave up on an interval, if f prime, so the derivative is increasing on that interval, and the graph of f is concave downward, and we could, downward, on an interval, and that's of course the opposite. It's like a cup is opening down, like you flipped your bowl upside down. And so the graph of f is concave downward on an interval I if f prime is decreasing on that interval. So we have a test for concavity, and our test involves a second derivative. And so let f be a function whose second derivative exists on an open interval, and we've seen some stuff like that on tests, right? We say it's a twice differentiable function. And so if f double prime of x is greater than 0 for all x values on that interval, then the graph of f is concave up. So concave up opens up. And if f double prime of x is less than 0 for all x on that interval, then the graph of f is concave down. So to kind of relate like these new pieces of information, let's go back over to our fun chart and kind of see like graphically what this means. So if we have a function, like, and this would be just basic, right, a quadratic parabola. If my quadratic is concave up, then that means that on that interval my function has to be increasing, my derivative is increasing, and my second derivative is positive. It just has a positive value. If my function is concave down on an interval, that means my derivative is decreasing on that interval. It's going down. Now, just because it's going down, we don't know if it's a positive or negative. So you kind of have to relate some things here, thinking about the differences between a positive value and if a function is decreasing or increasing and a negative value. So if we're concave down, my derivative is decreasing, my second derivative is negative. Now if we're talking about our function, and this was like kind of all of our first derivative test over here, right? If my derivative is positive, that means my function's increasing. And if my derivative is negative, that means my function is decreasing. And we're going to use these things to talk about a bunch of stuff. So what's happening, and we're going to pause here and we're going to go to another video.